Hey everybody, welcome to Rob's Fix-It Shop. I'm working on this other project where I'm trying to take a guitar amplifier and make it battery powered. And so one of the things I'm doing with that is I'm replacing the transformer with a power supply that I can run off 12 volts. And so I bought this board here, and it was the closest thing I could find. It's got minus 32 volts and plus 32 volts. So it's got two rails. It's got the plus and minus rails, which is what I need for an amplifier. And there aren't a lot of boards like this around. And so it's way too big for what I need. It's about 180 watts it's advertised as. But it's also fixed at 32 volts, right? And so I thought I wanted to figure out a way that I could make it to 24 volts and minus 24 volts that I need for this amplifier project. And so so that's what I'm going to do today. I've worked on this quite a bit. I didn't quite understand how it worked, but I feel like like I understand it now. And so I'm just going to figure out a way that I can use it to do the minus 24 to 24 volts and use it for this other project. But I thought it would be fun to kind of come along and see if I can get this thing to do what I'd really like it to do. So here's the board. I've already done some alterations to it. I put in a voltage divider on the output, and I pulled out a couple of resistors. And the board looks pretty nice. It's got a big filter capacitor area. It has the power transformer. It's got a Texas Instruments. So this power supply has a TL494 pulse width modulation control circuit, and the way that works is they have a sawtooth wave that's created in there, and the speed of this wave you can control by the external parts. And what they do is they then have a reference voltage that they look at, and then depending on the reference voltage it creates a pulse width, right? And then that pulse width, well, actually it creates two, and they're off phase with a small dead time in between. And then what those do then is they are pushed through a driver and then through a MOSFET. And those MOSFETs are essentially connected to, let's say on mine it's 12 volts, but then they're connected to a transformer. And what they do is they pump back and forth. They pump a current back and forth through here, and that induces, and then that's pretty much goes to the other side of the transformer where you've got a rectifier bridge. And you produce a voltage in here. How long these widths are determined by these op amps right here and pin 4, which is the dead time compensation. So the dead time compensation is going to be affecting the amount of time between the pulses, and those op amps are going to be figuring out how wide the pulse width has to be. And so I reverse engineered the circuit, and what you find is, here's the two comparators here and here. So they call these, so here they call these two guys here error amplifiers. And they're right here and right here, and this one's just grounded out, and this one's just fixed at high. And what that's going to do is that's going to put the duty cycle as high as it will go full time. And then here you've got a voltage divider, and what that's going to do is that's going to set your dead time, but it sets the dead time very small. So what's happening in here, and so here you see pin 9 and 10 are where those pulses are coming out. Those pulses are coming into driver transistors, then into MOSFETs, and then into this transformer here. And this thing's running full out all the time because this is just fixed at full, and this dead time is set really small. And so it's pretty much setting out 32 volts no matter what. There's no feedback from the output back to here that I could adjust to reduce the amount of voltage coming out by pulling in those pulse widths. So I've been looking at the spec page, and what I've found is that if you take the output and put it through some kind of a divider so that a voltage divider so that you end up with 2.5 volts coming out of the voltage divider at your target voltage. So let's say your target voltage is 24 volts, which is what I want. You want the output of this voltage divider to be 2.5 volts. And if you bring that in to pin 1, and then on pin 2, you want to essentially take your 5 volt reference off this chip, put it through a voltage divider, and then have 2.5 volts as a reference. And then if you have those two, then that should be all you really need to control the pulse width of this chip. Also, there's another voltage divider over here that's going to set up the dead time compensation. So that's going to set up so that when one signal goes high, the other one goes low a little bit later, because you can't be pumping both those MOSFETs at the same time. Okay, so I think what we're going to do here is, here's the circuit diagram right here for the error amplifier section, and so we're going to take the 5 volt reference, which is off the chip, and we're going to use a voltage divider, and we'll just 5.1K, 5.1K, and then we'll take that 2.5 volts and we'll bring that into pin 2. And then we'll take the output voltage and we'll split that between a 4.7K and a 1K potentiometer. And this is what I'm hoping will allow me to dial in the output voltage. And then also they said for stability, take the output and use a 51K, is that right? Yeah, 51K resistor coming back, feeding back into the low side. A resistor here, a 510. I'm not sure why that's there, but so I'll set this up. And the other thing that we need to look at is because the circuit had something for the dead time, but we're not going to be able to use it, I think what we're going to want to do for the dead time is this circuit right here. This capacitor right here, that affects how long it takes the dead time to kind of come up. So we got 5 volts, we've got our capacitor right here, and then we use a voltage divider here to determine the amount of dead time. And I think in their sample here they're using 9.1K and 1K, and so that's what we'll use in here as well. And that goes into pin 4, which is the dead time, which is where we adjust the dead time. So I think we'll set this up and see if it works. So I gotta free up this pin 1 here. Okay, so now pin 1 has its own trace there. Okay, so here's what I think I'm going to do. So this whole network here, I'm going to drill holes here, 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 here. That's going to be these two, this voltage divider. Then the 510 is going to go here, and the 51K is going to go here. And then I'll run the jumpers underneath. And yeah, so that'll fit in pretty nicely. This here, I've already got in place over here. And then this part here is gonna, I think I'm gonna be able to use these existing tracks for that with a couple of jumpers. So I'll go out and drill this, and we can try putting it together. Okay, so I'm making some progress here. If we look at these two resistors right here, and this is the 510 right here, and this is the 51K right here, and then on the other side the these two, this one goes to ground right here, this one goes to the 5-volt reference, this one, number 2 right here, or it goes to pin 2, this one here goes to pin 3. So those are all wired up. And now the last thing I have to wire up is this part right here, which is the circuit to control the dead time between the pulses. And so but there was already, that was the only circuit that was in here, so there's room for a capacitor and 2 resistors, and they both go into pin 4, but they used to go to pin 2 for power, and pin 2 isn't power anymore, or the 5-volt reference, I mean. And so I'm just going to have to get the 5-volt reference over to here, and I should be good then. And I should be able to use these holes for the resistors then. And here this is recommending a 9.1K and a 1K. So I'll get those installed, and I should be ready to go. Okay, so I rewired this part of the circuit here. This is the dead time compensation, and so yeah, so it's just a voltage divider between the 5 volts reference and ground with these 2 resistors and then a little capacitor. They already had that in the circuit before, and I pulled it out, but yeah, so it's nothing special. I just soldered in the different resistors than this thing started with, and the different capacitor. And then here I had cut this trace between pin 2 in here, which used to have the 5-volt reference, and so now I had to just kind of run the wire from here over to the 5-volt reference pin, but the ground was already hooked up, so we're all good there. So I think it's ready to try turning it on and trying it out. Alright, so I have these dummy resistors set up over here, and I have my current limiter on, so I won't burn up too bad if something's wrong. And I have my scope hooked up to the pulse on the gate of the MOSFET. So I turn it on, turn my current up. I'm going to turn it up to 10 volts. Oh. Okay, so now it's at 10 volts. Let's check our output voltage. Minus 25. 25. That's good. Okay, so I'm going to turn up the input, or turn down the input power. That's what I didn't want to happen. It said the output power is tied to the input power for some reason. Let me see if I can change the output here. Okay, so something's messed up because I can't change the output there. So I'm going to look at what's coming into pin 1, which should be around 2.5 volts. Okay, so now we should see our voltage coming down. Nothing. So let's look at the other pin here, pin 2, which should have 2.5 volts. Okay, that's 5 volts. So something's wrong there. So I'm getting around 5 volts right here and into here, which is way off. So I'm thinking that this is pin 2 here, and pin 2 used to be connected to the 5 volt reference, and I'm wondering if I just didn't cut the traces well enough. So I'm going to take a look at that, make sure that those traces are cut, and I bet that'll take care of the problem. Well, there's my problem. There's a trace from the 5 volt reference over to here underneath the chip. So I had to lift up the chip, which wasn't particularly easy. But yeah, there's a trace on the bottom and on the top, which seems kind of weird to me, but there it is. Okay, I'll just have to cut that trace out too. Alright, 0. Kind of a long and windy road there, but I'll have to straighten these pins out and get the chip back in. Then we'll try soldering up and try it again. Okay, so it's all back together. I have this is my wire coming from the voltage divider over here to pin 1. And then pin 2 down here is going to, you've got this voltage divider going to the reference voltage and to the ground. That comes to here, and then through a small resistor right here, and then back to pin 3 comes this wire right here. So we'll turn it on and see what happens. See if it smokes. Okay, so I just got a little bit of current going into it. I'm going to increase the current. Actually, I'm going to increase the voltage. So I've got about 12 volts. Looks like we got a nice pulse there. And, oh, okay, so we got 28 volts. And then our, let's see, our reference voltage on pin 2 is 2.3 volts. So I think we're right in the ballpark. So let's see if I can adjust it. There. Pulse is getting smaller. And our voltage is going down. It's exactly what I wanted to happen. So there's 24 volts. So let's check what our reference is now. 2.536, and our divider is right around the same thing. So that makes sense. So the divider and this divider, these two dividers are matching up. And let me turn the voltage up. Perfect. So as we turn the voltage up, our pulse width spreads out till we drop yeah, we need at least 9 volts. So at 9 volts, then we go up to 20. We're still working okay. You know, I think I could do better if I didn't have as much dead time. Let me try reducing the amount of dead time. I think what's happening is we're getting too much dead time in here, and that's not allowing it to build up enough of a pulse. Let me experiment with that. So I'm looking at the dead time, and the dead time here is, so I did a little reading, and it says that the dead time, if you just short it to ground, it will be about 3%. And I think now if I'm using a 120 ohm resistor here and a 9K resistor over here, that that's pretty close to almost nothing on the dead time. So I'm just going to solder that in. I don't think we're going to get any better. And you can see here, as I turn down the voltage, I'm at about 9 volts now. We can't really increase the pulse width anymore because each pulse can only go 50%, and we've got that dead time in between. And so once I go below a certain voltage, I think around 8 volts, then we're no longer adjusting the size of the pulse width like that. That's right about there, and that is, let me check, that is 9.6 volts. So I wish it were a little bit better, actually. But I don't think, I don't think we're going to do that. And also, I've got a pretty heavy load here. I've got the full current on it. If I reduce the amount of load on it, .3. Yeah, it stays about the same. So I think 9 volts is where we start tapering off. But even after we taper off, then we start losing our output voltage. But we still have quite a bit, so it's not the end of the world. So here's the final on the schematic. Now that it's doing what I want it to do. So coming in from our output of our output voltage, we have a voltage divider with a 1K potentiometer here so we can adjust the voltage, and that's coming into pin 1, and this guy comparator is comparing that to the 2.5 volts that, or a little bit less than 2.5 volts, that's coming through this voltage divider. and so it's comparing those two. And then from the spec sheet, or from their sample circuit, they had this 51K back to 3, which is actually kind of coming like this, I guess, for stability. I didn't try it without it not there, but it seems to work with it there. And then for the dead time, I have the dead time as low as I can get it here. And I did look at the scope to see the output, that it's not, that the two MOSFETs aren't overlapping each other at all, and they're not with this. And so I think, you know, we started out with this circuit, right, where this was completely isolated, where this side was completely isolated, and this guy was just pumping out as much power as it could, which ended up being minus 32 to 32 volts. And instead we took some feedback back here, brought it into the comparator here, and compared it to a reference voltage. So what we really did is we took this output here, we brought it back, we divided it so it was around 2.5 volts, and we brought in a 2.5 volt reference here, and brought that into the comparator. And now the comparator is what's adjusting that pulse width. And we can see that here. We can see this comparator, or this voltage divider and this voltage divider coming into this comparator. And then we also have the dead time compensation here. We're adjusting that as well. And the thing to remember is that this is non-isolated. In this circuit here, our two grounds are separated, but they no longer are. The grounds are connected between here and here. So if we look at the board, I did have to pull the chip out and cut a trace underneath the chip, but really what I've done is I've cut all the traces that used to be connected to pin 2 and some of the other traces, and just kind of rewired it so that I come from, here's the 5 volt reference right here, and so the 5 volt reference is coming into the voltage divider here. It's going into this voltage divider over here, and then pin 3 then is coming up through here to this resistor. Pin 2 is coming to the output of the voltage divider, and then our reference is going to one side of the voltage divider, and our ground is coming to the other side of the voltage divider. And you can see that I just drilled holes in here and put these resistors in here to do that work, and that worked out pretty good. There's kind of open board here, but you had to be a little bit careful drilling that out. And then here is where I have my voltage divider for the output, coming from the output, coming into here, dividing, coming up through here, through the potentiometer, and then the center of the potentiometer is coming back to pin 1 for that reference. So, I don't know, I thought that was a pretty fun project. I mean, it took me a lot longer kind of figuring it out, because I got kind of hung up on trying to adjust everything just using the dead time compensation, and which was a bad idea. And then went back to the spec, used the spec to kind of figure it out. And so if you found this interesting, please hit like and subscribe. I just love to do stuff like this, and so I'm going to be doing a lot more. And so thanks for joining me.